So, what is the tangential speed, and how can you be able to express the relationship that exists among the linear quantities as well as the circular motion quantities, and are based on the tangential speed and also angular acceleration? For instance, let's say we have the object, and that should be the object that wishes to move along the circle. Let's say the circle with the center of, that should be the center given as that, not being that of center of, but just have to literally say this is the center of the circle. So now, whenever an object is moving, let's say this is the case, and they're assuming that this is the object. So, whenever an object is moving, as we already discussed this one in when we were discussing about, that is a centripetal acceleration. Whenever an object is moving in a circular path like this, let's say the circle is of, let's say, radius given as r. So now, at each and every point, whenever the object is moving in a circular path, let's say it is going towards, it is moving anti-clockwise direction, always there is a tangential velocity which is always tangent, as the name itself suggests, which is always tangent to the circle. That is at each and every point. So this is given as a tangential velocity given as actually a v subscript t, or we may say linear speed or the linear velocity. If the object it is at this point, then also have the tangential velocity that is given as that. So given as that, and whenever the object at this point, the tangential velocity also changes the direction. It can be that, and at this point the object is also having the tangential velocity, which is in this case. So now, in this case, how can you be able to express the tangential velocity with respect to the object moving in a circular path? So understand the linear velocity, or should be the linear speed, the linear velocity is given as the distance, that is the displacement, the distance over time. That is the formula for the actually a linear speed or the linear velocity. It can be that. Now, since we're talking about the object which is moving in a circular path, then this is actually a tangential velocity will be given as a vt, that is the linear speed or the tangential speed or the velocity. And assuming that the object has completed the one revolution or the one circle, then this actual distance will be expressed as in terms of the now angular displacement, that will be given as the 2 pi. So it should be that. Rather should be expressed as the circumference of the circle. If the object has completed the full circle, then it means we'll have this one as the circumference of the circle. That will be given as the 2 pi r, because the object has moved from this point all over and back to the same point. So which means the circumference of the circle will be given as the distance. That will be given as 2 pi r. In this case, it means the term x will be given as the period, that will be given as t. So what is the tangential speed? We'll have it as being given as, we should have to understand that having this case, you know, this is the same as having it as the radius now times 2 pi over period, and of which this one is said to be the angular velocity. Hence, we'll have the tangential speed being given as the radius times the angular velocity. So that's how the linear quantities as well as the circular motion quantities can be expressed in that way. So which means if we have the radius of the circle and if we have the angular speed, we can be able to have the tangential speed or linear speed using that formula, and it is given in meters per second. So take note of that. Likewise, if we have the tangential speed, the angular velocity can be able to have the radius of the circle given using that formula. So bear that in mind. So let's say this is the question. Find the angular speed. So we are looking for the omega. And a circular object must have to give a linear speed of, now this is the tangential speed, the linear speed, 1.25 meters per second. When it's actually when it's 2.5 centimeter from the center. You know, I have the wrong presentation of this question, but when it's 2.5 centimeter from the center, and B, when it's 6 centimeter circumference. So what is that one? So we have been given the radius because 2.50 centimeter from the center, which means that's the radius. So have that in meters. The radius has to be in meters, so have 2.5 times 10 to the power negative 2 meters. So that is the radius. So what is the angular, what is the angular velocity? So the relationship says that the tangential speed is equal to radius times the angular velocity. So we have this and this, we can be able to have the angular velocity. And likewise, the question B, we have been given a circumference of the circle. That is the circumference of the circle, which is given as a circumference is equal to 2 pi r. So we have it as given as that. Now should be this one first. The circumference of the circle is given as, now we are sure that it is given as 6.00 centimeter, which is the same as 6.00 times 10 to the power negative 2 meters. That's how it has to be in actual meters. Then we are sure to have the angular velocity, that is that. So, and given the tangential speed, which is given as 1.25, which is the same. So the formula says that the Vd is equal to the radius times the angular velocity, of which we do not have the radius. But since we have the circumference of the circle, we have it as, the formula for the circumference is given as 2 pi r. We have 6.00 times 10 to the power negative 2 is equal to 2 pi r. So you can be able to solve for the radius there. So take note of that.